So the general form when we write out a reaction is we start with our reactants. That's what the things we mix together for our reaction to occur. And then we have an arrow, and what we end up with is called our what? Products. So the next part shows you a sample reaction. So we've got hydrogen gas, H2, plus oxygen gas, O2. That's what we're starting out with. So those are our what? Reactants. And then our product is water. So we end up with one product. This will show you reactants and products, and also what the numbers are. So the numbers in front, the big numbers in front are called coefficients. And we'll talk about when we change those is when we balance reactions. And the bottom numbers are subscripts. And the subscripts come from how the atoms bond together. So in this unit, the subscripts, we're just going to have to take at face value because we haven't talked about bonding yet. When we talk about bonding, you'll see where those subscripts come from. In this unit, we will go over balancing reactions where we change the coefficients. Who's balanced chemical reactions before in other classes? Yes? Cool. Is a chemical reaction. What has to happen in a chemical reaction? And then how does that compare to a physical change? So which one do you guys want to talk about first? Chemical or physical? Chemical? Okay, so in a chemical reaction, let's take, for example, water. If I have water, liquid, and I put it in a freezer and it becomes solid, is that a chemical change? No. Why? It's still H2O. It's still chemically the same substance. So what kind of change occurred? Physical. So for a chemical change, what could I do with water that would be a chemical change? Break it apart into hydrogen gas and oxygen gas? Anybody know of a way you can do that? Drop a 9-volt battery into a beaker or a container of water. You'll see bubbles. Okay, don't do this at home. I mean, you can. Your parents may not want you to use 9-volt batteries to do that. But it will bubble, and that electricity is causing the water molecules to break apart. It's called electrolysis, and it gives off hydrogen gas and oxygen gas. So if we started off with H2O and end up with H2 and O2, is that a chemical change or a physical change? Chemical. So what can you guys come up with 2 examples of physical changes?
Color and shape.
Those would be properties. But so what could change? Like if it was a circle and we cut it in half, is that a chemical change or a physical change? Physical change. What's another one? Ripping a piece of paper.
Boiling water.
Boiling water. Very good. So all of the changes of state, freezing, melting, boiling, condensing, are physical changes. What about chemical changes? What are some examples? Burning. Is that what you said? Burning. Yep. What else? What are some things you learned about in biology that are chemical changes? You probably had to learn the reaction for photosynthesis. Yeah? Photosynthesis is a chemical reaction. What's the opposite of photosynthesis? Huh? What humans do that's opposite of photosynthesis? Metabolism, right? oxidation of glucose that's produced from photosynthesis. Resting is chemical. Cooking, pretty much anytime you cook something, it's going to undergo some kind of chemical change. There's a few exceptions, like if you're just adding water to something, it may not actually be changing chemically. But like if you cook an egg, that is changing it chemically. When you're baking, that's changing it chemically. So those are all examples of chemical changes, where we end up with a new, chemically different substance. So we're going to talk about reactions now. So one thing that is important when we write out a chemical reaction is that we include, as best we can, the state that the substance is in. And so you're going to see this throughout. So this will be kind of like our key. So if the substance in our reaction is a solid, then next to its formula, in parentheses, we're going to put an S. If it's a gas, we're going to put a G. If it's a pure liquid, we're going to put an L. And then an aqueous solution means it's dissolved in water. So aqueous would look like a liquid, but it's like if I dissolved salt in water, it wouldn't be a pure liquid, it would be what we call an aqueous solution. So if I was reading through this, I'm going to start out with a solid, which is zinc, and an aqueous solution. So I'd start out with something that looked like a solid and something that appeared to be a liquid. It's aqueous because it's not a pure liquid. And what do we call that? The Zn and the H2SO4. What are those called? Our reactants or our products? Reactants. That's what we start out with. And then it's going to produce another aqueous solution, so zinc sulfate, and then a gas. So what do we call those? The ZnSO4 and the H2, our products. And so as this reaction took place, we'd drop a solid into an aqueous solution, and we'd see that solid disappear, right? It would disappear. We couldn't see it, right? And then what would we see forming?
Different aqueous solution, but the gas coming out of it.
So what would that look like? When we say aqueous solution, we functionally mean a liquid. So if you have a solid, bubbles. Very good. And the last question asks about the subscripts. So we said the subscripts when we are in this unit, those we're going to leave alone. We don't know where those come from. We don't know the rules for where those come from yet. But they tell us how the atoms bond together. And we will get to that when we talk about bonding in a couple of months. Okay? You guys go ahead and write down this reaction, then we'll talk about it. Okay, what are our reactants? Good. Solid magnesium, which is a metal, and oxygen gas. Are we going to see oxygen gas? No. Oxygen gas is a colorless, odorless gas. We wouldn't see it. What's going to form is also a solid, and it's called magnesium oxide. So we only form one product, and that's the MgO solid. The numbers out in front, the 2, and then there would be a 1 here. We just leave it off because it's assumed to be a 1. And then a 2 in front of MgO are our coefficients. We said, what did I say we're going to use the coefficients to do eventually? To balance a reaction? And we'll get into that. We'll do a whole separate lesson on balancing. So if we look at our reaction for the question D, it says list the amount of atoms in the reaction. So I'm going to do reactants on one side, products on the other. So in my reactants, how many magnesiums do I have? 2. And how many magnesiums in my products? 2. Does everyone see where the 2's came from? What about oxygens in my reactants? There's 2, right? We take the coefficient and multiply by the subscript. So what's 1 times 2? 2. No. So in this reaction, what are our reactants? The C3H8 and the O2. And then the products, the CO2 and the H2O. Good. So in this reaction, we're starting out with 2 gases. Propane does have a little smell, so you would probably smell the propane if it was just happening in open air. But then the products that are formed, carbon dioxide gas and liquid water, you may see liquid water condensing. You may not. It may be hot enough that all of that water, even though it forms as a liquid, really just vaporizes into a gas. This is, who's used a propane tank? I can do this. I'm pretty sure on like big home grills, it's propane that you use. And then the little tanks, if you've ever like gone camping with little tanks, are butane. But this is the reaction for the burning of propane. Do you guys see where it says gas? The G and the G and the G and the L? Okay, what about this next one? Is this a chemical reaction? No, why not? Because we still have H2O. It's just H2O that's a liquid becoming a gas. So this would be a physical change. And what's the name of that physical change? Liquid to a gas is boiling.